Hello everybody, welcome to the homework helper for section 2.3. Let's go ahead and get started. We're going to be doing fractional exponents to get things started off, where what we're going to be doing is converting these radicals into fractional exponents, right? So whenever we have a radical, that the number in the radical, the 5 for instance, is going to be the denominator of our fractional exponent. So this is the 5th root of x, which means it's going to be x to the 1/5 power. Here we have the 7th root of s squared. So when you're thinking about this, you can think s squared to the 1/7, and then they multiply, so it becomes s to the 2/7. Okay? But then you can also kind of see that the power that's on it goes in the numerator, and then the root that we're taking, in this case the 7th root, goes in the denominator. Okay, so that's kind of one way to think about it if you're trying to move quickly or you're feeling a little bit more comfortable. You know, for example, let's jump down to a more complicated one like number 7 here. We're taking the 3rd root. So this is going to be 9b to the 8th to the 1/3. And then that 1/3 is going to apply to everything. So it's going to apply to the 9 and the b because they're multiplying together. So that's going to be 9 to the 1/3 b to the 8/3 because those multiply together. Okay, so keep that in mind as well. Okay, next what we're going to be doing is we're going to rewrite with a fractional exponent and then find the answer of these logarithms. So when I'm looking at this one here, when I'm looking at log base 3, 5th root of 3, I can rewrite that with a fractional exponent, right? That's going to be log base 3 of 3 to the 1/5. And now it's one of those things where the base and what we're evaluating it is the same. So what does that mean? And luckily, I included a cheat sheet for all of us on the inside of your front cover here. And so when we're looking at that, when we have the base, this is rule 6, when we have the base of that term that's being raised to the power, we know that when we evaluate it, it's just going to be the power. And that kind of makes sense because we're trying to figure out what all of these different powers could be. So this is just going to be, this log base 3 of 3 is going to even out. So this is going to be 1/5. Okay? But I'm going to ask you to do that with some things that are maybe a little bit more complicated. So look at this. This is log base 2 of the cube root of 4. All right, let's rewrite that. Log base 2 of 4 to the 1/3. But now you might be thinking, well, this isn't exactly like number 9. What do we need to do here? Well, what we need to do here is we need to get 4 to have a base of 2, right? Because we could easily write 4. 4 is the same as 2 squared, 2 times 2. So if I write this as log base 2 of 2 squared to the 1/3, well, I'm getting closer now, because this is going to be the same as log base 2 of 2 to the 2/3. And now it's just like number 9, where the base and what we're evaluating it are the same. The base and what we're evaluating it are the same. And we saw that that ended up being just whatever that exponent is. So that means when we evaluate this, it's just going to be 2/3. Boom, boom, boom. Okay? So keep that in mind as we move through those. Okay, so now we're going to be moving on. And so we're going to be using the properties of logarithms to expand logarithmic expressions. Now, expand is like the opposite of simplify. What we're trying to see is how all these rules work together so that we can bring things apart before we bring them together, et cetera, et cetera. So when I look at number 13, which is log base 5 of 7x, well, 7 and x are being multiplied by each other. And again, I'm so kind to give you this little cheat sheet on the inside front cover. Wait, do I know where it is? There it is. Okay, so look, when we have two numbers that are being multiplied together, what we do is we take log base b of the first number and we add log base b of the second number. Same thing with division. Okay, so let's go ahead and expand some of these things out. When I see that this is log base 5 of 7x, that's 7 times x. So that's log base 5 of 7 plus the log base 5 of x, right? And so the same thing here. This is going to be log base 5 of 10 plus log base 5 of a. And then when we look at division, it was subtraction. So this is going to be log base 5 of 5 minus log base 5 of b. But it'll get a little bit more complicated with ones like 17, right? Base 6, but we're cubing. How can we do that? What do we do for that? Well, once again, I included some easy answers. Okay. So now when we're raising it to a power, we have these different powers here. That power can be multiplied to the log outside of it. So when I think about that, that means this 3 can be multiplied there. So it's 3 times the log of 6, base 6 to x. Okay. Ooh, what about this one? Well, I could rewrite this. This is what's cool. I can rewrite this as log base 5 of 9 plus log base 5 of x squared. But I can also do that as 2 times the log of 5x. Yeah. And even this, 9, well, 9 is 3 squared, right? So I can actually write this as 2 log base 5 of 3 plus 2 log base 5 of x. Pretty cool. So it's mostly what we're trying to do is try to expand these things out, see how these rules work together, try to pull them apart as much as you can, because the more comfortable we are with those rules, the easier everything else will be in the future. So there's all those. A few more on the back side. Here we'll be subtracting some things, right? This is going to be log base 5 of x, y, and z minus the log base 5 of w. But x, y, and z are multiplying by each other. So this is log base 5 of x plus the log base 5 of y plus the log base 5 of z minus the log base 5 of w. Ooh, what an expansion. What a fun expansion. All right. Next, it wants us to write these in logarithmic form. And remember, whenever we're doing logarithms, the exponent is what it equals to. So the exponent is what it equals to. So this is going to be log base 2 of 512 equals 9, right? Log base 2/3 of 3/2 is -1. Okay, and from here you can see where, like, maybe when we start expanding things, it gets a little trickier. But all that we're doing is making sure everything is moving where it needs to move. Okay, this is doing the same sort of thing, right? Remember, the exponent is what it equals to. So these are our exponents. These are our bases. So this is 1/3 to the exponent will be 3. And sure enough, we actually, whoops, let me scoot that up a little bit. Sure enough, we know that that's true because the inverse of 1/3 will be 3. All right, that's it, everybody. Be sure to ask questions and good luck.